here today to announce the largest acquisition program in the history of the Department of Defense.
Roger, copy.
The Joint Strike Fighter.
And just for the record, pilot, yeah, you are my hero.
In the skies over the Mojave Desert, a battle of X-planes has begun.
That looks good.
Over the next year, 2 different planes will take to the skies again and again on a relentless quest to be crowned the fighter of the future. Perhaps the last manned fighter the U.S. will ever build.
Oh, it smooths out beautiful. This is fun.
Great, it was super, yeah. Thank you very much.
So awesome.
Oh, it felt great.
We're going to fly the out of this airplane and just kick every day. That's what it's all about.
It's all part of a top-secret competition, locking 2 of America's aerospace giants in a furious engineering dogfight to the death.
You couldn't have a more interesting competition. 2 very different companies, 2 very different designs. Conservative heavyweight against a radical newcomer.
We got a hell of a smart team, so let's go figure out how to make it work.
Whoa!
There's never really any time to relax. Would I like to be further ahead? Yes. Would I like to be farther done? Yes.
I think we truly believe that we've got the right vehicle for the customer.
It's starting to look like an airplane. That's what's really neat about it.
Well, I see a future contract.
Well, that too.
Not just any contract, but the most lucrative contract in military history. At least $200 billion.
Control steering is off.
And the winner won't be just any fighter. It will need to land on a carrier, evade enemy radar, hover like a helicopter.
But trying to build a fighter that can do all 3, it's a tremendous challenge.
It's not a natural thing for a jet airplane to do.
Come on, Simon.
Experimental new designs come with their share of risks and failures.
The 402 left to the down.
But now, the U.S. military desperately wants a winner, claiming that aging fighters and shrinking budgets threaten to undermine its command of the skies.
Going to 76.
Will a one-size-fits-all fighter, a joint strike fighter, work for the Air Force, the Navy, the Marines? Will it rescue them from the death spiral of defense costs? With unprecedented access from the Department of Defense, Nova's cameras take you into the U.S. military's most classified facilities. From the beginning to repeated trial and error.
Can I reset? Negative. We're recommending we abort.
The original design wasn't gonna hack it.
How much effort is ahead of us to make it work?
Watch 2 teams struggle to get their daring ideas off the drawing board and into the air.
The Joint Strike Fighter will be the world's premier strike platform. With a decision to proceed now made, it is now appropriate to announce the winner of the Joint Strike Fighter competition.
In the end, only one winner takes all. In the Battle of the X-Planes. Up next on Nova.
Major funding for Nova is provided by the Park Foundation, dedicated to education and quality television.
Science. It's given us the framework to help make wireless communications clear. Sprint is proud to support Nova.
And by the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you.
Inside this bag is the future of American fighter power.
There will probably never, ever be another program as complex as this or as big as this when you start talking about dollars.
It's called the Joint Strike Fighter Program. For 5 years, the JSF has held a competition between two titans of aerospace to see who will build the next generation fighter. It's a prize worth up to $200 billion. And the winner's name is in the bag.
The winner of the JSF competition is going to dominate the fighter aircraft market, not only here in the United States, but worldwide.
Fasten your seatbelt and put up your tray table. NOVA and the Department of Defense have cleared you to enter places where cameras have never gone before. From secret installations to the cockpits of the latest experimental fighters, you've landed in the classified world of the X-planes, both high-tech and handcrafted, where pilots fly into the unknown with just you by their side. This is the battle to build the fighter of the 21st century. In the first strike in the war on terror, fighters are the frontline warriors. Navy fighters joined squadrons from the Air Force and the Marines to attack Taliban and Al-Qaeda positions in Afghanistan. These aircraft play a key role in routing the enemy, just as they did in the Gulf War in the early 1990s. In fact, some of the fighters are literally the same planes. Built in the 80s, designed in the 70s, to fulfill Cold War objectives from the 60s. The most important weapon in America's arsenal is based on ideas almost a half-century old.
Our airplanes, they're wearing out. They're tired. 30-year airplane, still a great airplane, serves purpose as well, but it's old.
These aircraft in the future battlefield, they're going to be a bit like dinosaurs. Not just in their sort of physical age, but their electronic capability. They may not be survivable.
We now have to go to higher altitude instead of lower altitude. We need to make ourselves as small as possible from a radar perspective. We have to do the same job, but the world has changed.
Almost all of America's fighters will one day wind up here, at the Boneyard at Davis-Monthan Air Force Base in Arizona. Old generals may fade away, but old fighters are cannibalized for parts. The Air Force still relies on thousands of these. The venerable F-16. But the F-16 is past its prime. In the age of stealth, this fighter shows up on radar the size of a small, flying house. This is an F-18, the mainstay of the Navy. But Navy planes get old fast. The controlled crash, known as a carrier landing, and the rapid acceleration of a catapult launch will eventually create irreparable stress fractures and send them all here. This is the subsonic AV-8 Harrier jump jet, flown by the Marines. While it remains the only successful vertical landing fighter, it dates back to the British invasion of America by the Beatles. Though later refined by McDonnell Douglas, by any measure, the Harrier is ready for retirement. The goal of the Joint Strike Fighter program is to replace all of these: the F-16, the F-18, and even the vertically landing Harrier.
It is absolute vital necessity to have not only a replacement airplane for the older airplanes, but to have an airplane that's a 21st century airplane to meet the needs for tomorrow.
The plane for the 21st century, at least for the Air Force, would appear to be already here. The new F-22 Raptor, scheduled for deployment in 2005. The Raptor is the ultimate fighter. So stealthy, its radar signature isn't much bigger than a bird. And it can fly at supersonic speeds longer than any other fighter. And that means it can strike deeply and invisibly at an opponent. But the Raptor has a huge vulnerability that the JSF program must overcome: a giant price tag. Each plane costs about $100 million.
The F-22 is a spectacular airplane. The problem is it's expensive. And that means the Air Force will never really have enough of them to attack the many and varied small and large targets that make up the modern battlefield.
The F-22 is just the latest example of a trend that goes back decades. Each new generation of fighters costs more than the last, so fewer are purchased. Ever more expensive fighters in ever decreasing numbers. In defense circles, that's known as the death spiral.
Where the death spiral could lead is the prediction that in the year 2054, the U.S. defense budget will only buy one airplane. So the Air Force uses the airplane in the morning, the Navy uses it in the evening, and the Marines, unfortunately, only get to use it every leap year on the extra day.
So that is the JSF's mission impossible: to break the death spiral by coming up with a new fighter that costs a third of an F-22, replaces all of these, and meets the needs of the Air Force, the Navy, and the Marines.
They absolutely said, you'll never pull this off. Impossible.
In the past, the fiercely independent services would have fought for their own weapons programs. In the 60s, when the cost-cutting Secretary of Defense, Robert McNamara, forced the Navy and Air Force to use the same plane, the F-111, the joint program was a resounding flop. But these days, with smaller post-Cold War budgets, the spreadsheet is mightier than the sword.
The Joint Strike Fighter program was a huge leap of faith for the services. The enabler, though, was they didn't have any choice. They knew that they had to modernize their fighter force structure, and the funds were not available to do that.
With no other options, the effort to design the Joint Strike Fighter begins. And almost immediately, there's a disagreement. The services can't even agree on the number of engines. The Navy's F-18 Hornet has 2 engines for safety. If one goes out, you don't have to ditch. But 2 engines are a deal killer for the Marines because of their weight.
You cannot build today a 2-engine vertical short takeoff landing airplane. So the Navy wanted 2 engines. Marine Corps had to have a single engine, and the Air Force wanted a single engine because it was much more affordable, and they don't have it. They're not out over the ocean at night all by themselves like we are.
The decision hinges on how dependable one engine can be.
Steady state 255 started.
After talking with jet manufacturers, the JSF team ramps up the specs for engine reliability. Rear Admiral Steidel convinces a reluctant Navy to go with just one.
That was another piece that was necessary to pull the program together. So without that, we could not have a common production line.
I think the effort that's gone on here to create a joint requirement is astounding, and it's really it's what's allowed the program to get where it is, and it will be what allows the program to continue, because if the services keep saying we all agree what we want and we want this aircraft, then it will happen.
Even with everyone on board, there's rough air ahead.
We know how to build a stealth fighter. We know how to build a long-range, agile fighter. We may even have a good way of building a fighter that can land and take off vertically. But trying to build a fighter that can do all three is very, very difficult.
The Pentagon spent over $3 billion in research to see if it was possible. And the answer? Sort of.
The airplanes are not the same aircraft, but the building blocks are the same building blocks for the most part. Same engine, same major avionics. In fact, it's not important to have every piece part the same, but the expensive parts or modules. Through the life cycle of the aircraft, there was the potential to save $60 billion. And that's a lot of money in anybody's calculus, even in the Department of Defense.
With the services in agreement about the requirements, the Joint Strike Fighter program launches a competition for innovative designs for the new, affordable family of fighters. Like a high-stakes game show, only 2 contractors can make it to the final round and build test planes. With billions on the line, U.S. defense contractors hold their breath as the Pentagon announces the 2 finalists for who wants to build the next generation fighter.
These contractors are Lockheed Martin and Boeing.
The announcement sends shockwaves through the aerospace industry, dealing a death blow to one of the most respected names in aviation. McDonnell Douglas, a company with a fighter legacy that seemed to guarantee a spot in the final round, doesn't make the cut. The impact for the company and its employees is devastating. Within 2 years, McDonnell Douglas is sold to Boeing, one of the JSF winners. A world leader in commercial jets, the Seattle-based company is seen as an unlikely contender in a fighter battle, for good reason. Boeing's last fighter was built in the 1930s, the P-26 Pea-Shooter, a fighter from the age before jets, before even a closed cockpit.
Boeing hadn't built a fighter in a long time. And I think early on, Boeing was considered literally a dark horse in this competition.
But the Boeing acquisition of McDonnell Douglas, the builder of the Navy's F-18, and the Marines' Harrier, makes a dark horse an even bet.
By acquiring McDonnell Douglas, Boeing suddenly moves from becoming the least experienced JSF team to possibly the most experienced.
Clearly leveled the playing field.
I'm in this job to win, and going back to...
Boeing's JSF effort is led by Frank Statkis, an engineer and 30-year company man. When you shoulder the weight of a potential $200 billion contract, stress comes with the job.
A year ago I had hair and it was dark. And now I have less of it, and it's a race to see what goes gray versus goes away. What's our G2 on the other guy?
While Statkis runs the project, he isn't the creator of Boeing's design. These days, with the complexity of fighters, no single person can claim that role.
State-of-the-art fighters. They're all designed now by computers, and these are big teams of engineers who sit down, you know, and do these CAD/CAM drawings. It's very tough to find, you know, one person who can sit there and tell you that I designed that airplane.
At the heart of the Boeing design for the JSF is a large delta, or triangular wing.
It's an unusual approach, but the big advantages of that are that it's structurally simple and that it contains an enormous amount of fuel.
Though there hasn't been an American fighter built with a delta wing since the 60s, the design has its advantages. The fastest jet ever to fly, the SR-71 Blackbird, has a delta wing because it decreases drag at supersonic speeds. The space shuttle is also built around one because it provides great lift. But neither the shuttle nor the SR-71 are exactly agile. A Delta design pays a price in speed when executing turns. And the control surfaces near the tail don't have the leverage to turn the plane sharply. European designers have overcome these handicaps in their new fighter, the Typhoon, by adding canards near the front of the plane. But in the U.S., Delta fighters have been out of favor for decades, until the JSF picked the Boeing design as a finalist. Why the new interest? Deltas can be cheap to build.
Boeing took a step back and said, what makes aeroplanes expensive? How can we leave it out? And they got a very, very simple design.
Boeing's expertise in wings has kind of taken a different tack. Our engineers have chosen to build this wing as one piece from tip to tip. We have always studied the idea of building a one-piece wing and attaching the fuselage to the wing. And so this time we had an opportunity to really try it.
Boeing has taken to heart the JSF concept, meeting the needs of the Air Force, Navy, and Marines through a versatile common design. And it even accommodates the biggest JSF challenge: landing like a Harrier. While it gets a bad rap for safety, the Harrier is no doubt the most adaptable fighter ever built. Matching its capabilities will drive many of the design decisions of the competition. When fully loaded with fuel and bombs, a Harrier takes off in as little as 500 feet, a third of that needed by most fighters. That short takeoff distance makes many roads into potential runways. After an attack, it returns, a lighter fighter, ready to execute its trademark Buck Rogers move. A Harrier hovers using rotating nozzles that direct engine exhaust downward. This mode of flight, called direct lift, demands an enormous amount of power. And it's dangerous. Before computer control, balancing a Harrier on its own engine thrust was like trying to sit on a geyser. Even today, its accident rate is 4 times that of a Navy Hornet. But through their flexibility, Harriers have proven their value. In fact, in the Gulf War, Harriers flew more missions than any other kind of fighter. For the British, the Harrier remains essential. British aircraft carriers are smaller than their American counterparts. The Harrier's short takeoff ability overcomes the problem and creates a portable fighter force.
The Harrier has allowed the UK basically to be where it couldn't be. The Falklands was a classic example. I mean, without the Harrier, we could not have defended the Falklands. We couldn't have got any aircraft down there. But the ability to put a reasonably competent combat aircraft onto a deck and get it down there and then fight was just the difference between success and failure.
But the Harrier can't fly supersonic, a serious limitation in a modern fighter.
In terms of its turn performance, its range and endurance, its maximum speed, whichever metric you want to look at, it fares unfavourably with any modern aeroplane.
We also have brothers in arms with the US Navy, so from
the British search for a replacement Harrier brings them to the JSF table. They become full partners. It's the first time a foreign government has been included in an American fighter development program. The addition of the British only heightens what many consider the central technical challenge of the JSF competition: landing the fighter vertically. Alternatives to the Harrier's direct lift system have been studied by both contractors, but Boeing has come to a surprising conclusion.
Over the years, all contractors have looked at all of these various lift methods, and the least impact of the design always and has been direct lift.
Boeing lift system is basically the modern version of the Harrier. Taking the engine thrust and putting it through a pair of nozzles that direct it downwards. The advantage that Boeing has is that you basically strap on the lift module around the engine, so the changes are pretty minimal.
The fewer the changes between the Marine fighter and the other versions, the better the bottom line. Boeing has made an ally of affordability.
So I believe when we're all finished doing flight tests, we'll have proven that direct lift offers the absolute greatest affordability because of the greatest commonality.
While direct lift is affordable, other parts of the plane must pay a price. For balance during hover, the engine must be in the middle. That leads to a gaping inlet to feed it air. To some, Boeing has designed a plane only its mother could love.
It's a strange-looking aeroplane. It's short, it's squat, the engine's in the front, not the back. It has this huge air inlet in front that reminds me of a hippopotamus.
This is a fighter competition, not a beauty pageant. But there is an adage in aerospace that if it looks right, it flies right. And appearance may be a deciding factor.
Appearance aside, Boeing's proposal is a cunning entry for the JSF competition. Throwing over fighter tradition, the company delivers a radical but simple design that promises to be cheap to build. Boeing's ready to give its aerospace opponent a flight to the finish.
When I daydream, I see it hovering, I see it taking off from airfields, I see it operating around the ship, and sometimes I even see it shooting down the Lockheed airplane.
Only in your dreams is the likely response of Lockheed Martin, America's largest defense contractor. For decades, in this secret facility in California, the legendary Skunk Works, Lockheed has designed and built aircraft that have blown through the boundaries of imagination.
The Lockheed Skunk Works reputation is founded on its ability to put together a small team of very motivated people, get everybody else out of the way, and leave them to solve a problem that everybody else thinks can't be solved.
The whole history of this place has been, there is nothing that we can't do, there is no project that we can't accomplish. There's a huge amount of pride of we can do anything.
We've done that. We've done that.
By the time Lockheed earns its place in the final JSF competition, Chief Engineer Rick Rezebek and his team have already spent 5 years designing their fighter. Now they must build a pair of test planes in just 2. If Lockheed wins, their work will live on for decades. If it loses...
The stakes are horrendous on this. This program will end up running from today out through the year 2050. Long after my retirement, the performance of this team and the decision-making that goes on during these next 2 years are very key.
The mystique of the Skunk Works remains unrivaled in aviation. It's the birthplace of America's first operational jet fighter, the P-80. In the 50s and 60s, this covert design house created the ultimate spy planes for the CIA. A high-flying U-2 and the high-velocity SR-71 Blackbird. Later for the Air Force, it built the F-117 Nighthawk, the first stealth fighter. Unveiled to the public during the Gulf War, the Nighthawk was the only U.S. aircraft to strike targets in downtown Baghdad. The image of anti-aircraft guns aimlessly blazing away at invisible attackers is a surreal salute to its success, and that of the Skunk Works.
They've conducted many of their most advanced programs in complete secrecy, such that nobody else in the world even had a clue what they were up to. It's got to be very, very scary going up against those guys.
The F-117 sacrifices speed and handling for stealth. It's been superseded by the current gold standard of American fighters, the F-22 Raptor, built by Lockheed. While very expensive and not the all-in-one fighter for the JSF, the Raptor provides a wealth of proven design ideas, including a radical new shape for stealth. It's no surprise the Lockheed design for the JSF inherits the Raptor's contours. Built around one common airframe, Lockheed's proposed fighter is modified for each service. Most visibly, the Navy model has a larger wing and tail for carrier landings. The exterior design of Lockheed's fighter holds few surprises. On the surface, it looks like the company doesn't want to gamble. It's on the inside for the Marines' vertical landing requirement that Lockheed's bet the farm. The company's gone with a daring new propulsion system known as a lift fan.
The lift fan has been an engineering challenge because there has not been a lift fan built before.
In the lift fan design, the engine sits in the usual fighter position in the tail. A drive shaft connects it to a large fan placed behind the pilot. To hover, engine exhaust is directed downward. But the fan is also engaged, taking in air from above the plane and blowing it out below. That creates two balanced sources of thrust, potentially a more powerful and stable arrangement than the Boeing solution. But to accomplish this feat, the drive shaft must be spun at an incredible rate.
Think of taking the propulsion system in a Navy destroyer, shrinking that down into a smaller package, putting it into a jet fighter airplane.
It's a technological challenge in the tradition of the Skunk Works. If successful, the lift fan will be revolutionary. But on the drawing boards, it doesn't blow away its critics.
It's a very clever solution, but it's got gears and bearings and a lot of moving parts. And in an operational airplane, you've got to make sure they work 100% of the time. If you're a pilot hovering at 50 feet and one of those parts fails, it's going to spoil your day.
Despite its complexity, the lift fan offers another benefit, invisible to the JSF sensors and test equipment, but plain to the naked eye: aesthetics.
You can look at the Lockheed Martin airplane and say, that looks like what I would expect a modern, high-performance, high-capable jet fighter to look like. You look at the Boeing airplane and the general reaction is, I don't get it.
Lockheed will build its test planes the same way it's built its successful prototypes of the past, as handcrafted machines, here in the Skunk Works. This facility provides a well-worn path to winning the JSF competition. Lockheed will try to triumph through daring new technology.
Just like Legos.
While Boeing tries to win with a bold, cost-saving design, combined with manufacturing know-how second to none.
You couldn't have a more interesting competition. Two very different companies, two very different designs. A conservative heavyweight against a radical newcomer. If Lockheed wins, it continues its decades of fighter manufacture. If Boeing wins, it could go on to dominate the fighter market like it dominates the airliner market.
I think we'll look back at this time, at this competition between Boeing and Lockheed, and I think it will be remembered as the Great Fighter War.
The next battle of the fighter war will feature close combat. Less than a mile away from the Skunk Works is Boeing's top-secret complex, the Phantom Works. And these two classified installations, the JSF competition is ready for takeoff. The schedule will be fierce by aerospace standards. In 24 months and on a budget of $1 billion, each company must build and fly not one, but two experimental planes. Adding to the tension, Boeing and Lockheed will remain in the dark about each other's progress. Nova is among the select few cleared to enter both facilities. Its footage locked away each night by security personnel. Boeing may not have built a fighter since the 1930s, but from day one, the company rolls out innovations to simplify the job. This scaffolding holds the parts as they arrive. The team uses lasers to position each component precisely in three-dimensional space, without having to wait for surrounding pieces. The parts themselves are designed so precisely that they fit together like puzzle pieces, with hardly any adjustment. Techniques like this lead Boeing to claim it can reduce assembly costs by as much as 75%.
It's a very interesting process, very new. Boeing's ability to demonstrate how the aeroplane is put together is certainly a plus, and that will weigh in their favor.
The frame for the single massive delta wing, the heart of the Boeing design, is already in the works. But the skin that will cover it is being cooked up over 1,000 miles away at Boeing's headquarters in Seattle.
After we put the pad up on, we'll probably need to cut it.
Engineer George Bible has spent the last year experimenting with a revolutionary material for the surface of the wings. It's a resin and carbon fiber mix called thermoplastic. In small quantities, it's been used on fighters before, but no one has ever tried to create anything as large as a 30-foot wing skin.
It's very challenging. We have no time or schedule to design something else, so we have to make it work the first shot.
Thermoplastic wings will be lighter and more durable than conventional wings. There may even be other undiscovered benefits, according to another engineer who first experimented with the material in the 80s, Frank Stadkus.
I personally would love to have thermoplastics on this airplane because I know that there's value in the future. Even though I can't tell you in all the areas where we might find that value, I do know it's there.
The future, in a word, thermoplastics. But right now, George Bible needs to solve some pressing problems. Making thermoplastic begins with these sheets of graphite, also known as carbon fiber, the same lightweight material used in fishing rods and tennis rackets. For the wing, it's laid down up to 90 layers deep on top of a giant metal mold, or tool.
We take layers of these graphite fibers and set them on top of each other, and then we put the resin in between to hold them together.
After 3 weeks of layup, the wing skin is tightly wrapped in protective bags, ready for the next step. A massive oven called the autoclave. The huge chamber acts like a pressure cooker.
The autoclave for me is always the most stressful part. You have nightmares at night thinking about all the terrible things your autoclave could do to it.
First, all oxygen will be removed to prevent a cataclysmic explosion. Then, with the wing heated to the melting point of lead, nitrogen will be pumped in, raising the pressure and exerting tons of force upon the thermoplastic, forcing the fibers to blend with the resin. In short, this is literally hell on earth. For the next 30 hours, George Bible will hold his breath until the cooked skin is removed from the autoclave and a perfectly formed wing skin is revealed.
Oh, she looks beautiful, doesn't she? Looks good. Looks very good.
But this skin is only the first. Boeing will need 3 more, one for each side of its 2 delta-winged X-planes. And although Bible is elated at his success, he knows that the next skin for the lower wing will be far trickier. It involves a more complex curved shape. And, in fact, when the next skin emerges from the autoclave, the first signs are ominous. Creases and folds on the surface hint at hidden structural flaws.
Man, that does not look good, those wrinkles. I'm afraid we're dead in the water.
An instrument scans the surface of the panel using water and sound waves to probe for air pockets that could fatally weaken the wing.
When we have a gap in the plies, the sound will not transmit through there well.
George Bible's worst fears are confirmed. The skin is riddled with defects.
Right now, I'm just exhausted. We can't get a break. I mean, it's just downhill. So we'll have to do what we have to do to get a panel down to Palmdale as fast as we can.
After hundreds of hours of work, the wing skin is worthless. With the first wing frame nearing completion down in Palmdale, Bible's team and its bold experiment are simply running out of time. Lockheed is facing a crisis of its own. The problem that has brought its entire assembly program to a grinding halt hinges on the holdup of a single crucial part.
We can have 99% of everything it takes to assemble the airplane, but if there's one part that hasn't been delivered yet and it's buried somewhere in the middle of the aircraft, you have to wait on the assembly work until that actually shows up.
Like Boeing, Lockheed engineers have tried to save money by reducing the number of parts needed to build the plane. One part in particular, Bulkhead 270, has ended up especially complicated. It will join the front of the plane, including the cockpit, to the fuselage. As a key piece holding the plane together, it's made of the metal alloy titanium. The combination of strength and lightness make it a natural choice for the bulkhead. But nobody at the Skunk Works had anticipated how hard it would be to carve such a complicated piece out of this super hard metal. Machining the 300-pound Lockheed part means whittling away at a solid 5-ton slab, the drills running 24 hours a day, using diamond bit saws and a special lubricant to reduce heat. The pressure to get the bulkhead done is enormous, but so is the price of any mistake.
If this part fails, it could almost ultimately be the end of our competition with Boeing in the JSF program. I mean, it would really set us back.
On top of the crisis on the shop floor, bad money management threatens to get Lockheed fired from the competition. In a program in large part about affordability, the company admits it's $100 million over budget. Lockheed blames part of the overrun on a $30 million accounting error.
In essence, what it was is we were writing checks without going back into the check register is what it amounted to.
Lockheed, yes, had a problem in the subcontract management business in their manufacturing end at Palmdale. It wasn't discovered until late. Very unfortunate, very disappointing. And the lesson there is, take nothing for granted.
It's a make or break point in the program. Under a powerful escape clause, the government can end the competition and award the fighter contract to Boeing. In the first real test of the military's commitment to fiscal limits, the JSF lets Lockheed off the hook. They're saved by the growing number of international customers now lining up to buy the Joint Strike Fighter.
We got Canadians, we got Italians, we got Danes, we got Dutch, we got a little bit of everybody. It ensures that for tomorrow in coalition warfare, we got partners with the same capability to fight the same wars as we do.
Ending the competition early would be a domestic and diplomatic debacle.
The government realizes that this program is so big and so influential on a national and in fact international level that their best bet is effectively to sweep this anomaly under the carpet. Let's forget about it and let's move on, and let's work under the assumption that Lockheed has learned a lesson and they won't let this happen again.
Although as disappointing as that was, the silver lining there is we're doing business a lot better and will continue for the future.
In the end, Lockheed gets slapped on the wrist for bad budget controls and presses on with the program, nearly a year and a half behind schedule.
We can't let 1 minute go by without paying attention to something out on the floor and getting it done. We can't be slackers anymore.
But back at Boeing, it's hardly been smooth sailing. The latest results from computer simulations are pointing to an alarming conclusion. Boeing's entire delta wing design may be fundamentally flawed. The Navy has refined its requirements and wants a more maneuverable plane that can carry more weapons. Boeing's delta wing design is now seriously overweight. Months into building the test planes, Boeing's lead engineers conclude that the only way to lose the pounds is to abandon the delta and come up with a new wing and tail design.
We are at a point in the process here where we need to make a decision on the tail. I think we're really struggling with which way to go.
An engineering team led by Dennis Muhlenberg must come up with a new tail design that will work on a reconfigured fighter. The conventional choice is called a four-poster for its 4 control surfaces, the tail design for all modern U.S. fighters, including Lockheed's Raptor and its proposed JSF fighter. But there is an experimental alternative, a novel 2-post tail with just 2 angled control surfaces. The Pelican tail is named after its inventor, an engineer inherited from McDonnell Douglas, Ralph Pelican. He argues its merits.
Sure, I understand you're all nervous about this new concept. I think it can be done.
Proponents of the Pelican tail argue that the design is less visible to enemy radar. In other words, it has a smaller stealth signature. For Boeing, this is an important plus, since Lockheed is the originator and acknowledged master of stealth technology.
I think we can't afford to have any question at all over our signature and whether we're making a signature.
I don't think that we really know enough about the Pelican tail. You know, we think we can make it work, but how much effort is ahead of us to make it work?
Those supporting the traditional 4-post tail argue it's a known quantity. The word on the street is that the JSF program managers favor it for the same reason.
There's a slight benefit from a strategy standpoint that we can negate a perceived Lockheed advantage by going to a 4-poster. On the other hand, we end up looking like the follower with 2 teams that have the same design.
I vote for the Pelican tail. I think we've got to bite the bullet and go there.
I guess maybe I'm still a little more conservative than Fred, and I would stick with the 4-poster and try and get the signature to work with the airplane with a 4-poster.
But your probability of getting hit...
The room is deeply divided.
I'm talking about if you have a failure.
In the end, Muhlenberg must break the tie.
Now, I've been a 4-poster fan up until about an hour ago. All right? I think we can beat the pants off Lockheed when it comes to working weight, handling qualities, aerodynamics. Whether it's real or not, they're perceived to have a signature advantage. So we need to do something to our configuration that will give us a signature advantage. I think the Pelican tail does that. All right?
Feeling pressure to make a bold choice, Muhlenberg chooses the Pelican tail.
About some things, so let's go figure out how to make it work.
But just days later, after Frank Statkus and senior management review the choices, Boeing changes its mind. Concerned about weight and performance, it commits to the more conservative 4-post tail.
Is signature versus weight. The 4-poster is a little safer way to go. So I was a little torn from a personal standpoint, but when we stood back and looked at the data, I think we made the right decision.
Boeing radically changes the wing and tail design, which gives the proposed fighter a fresh new look. The new plane is projected to be 1,500 pounds lighter and more agile. But it's too late to incorporate the design changes into Boeing's 2 test planes, now 8 months into assembly. Instead, the company will submit the new configuration with its final proposal. By testing the new design in simulations and wind tunnels, In flight testing the old design, Boeing believes it can prove the soundness of its approach.
To those of us watching JSF from the outside, this is the first sign that all is not well with Boeing design. Both designs are evolving as the requirements evolve, but it seems that Boeing's design is not as adaptable as Lockheed's. The requirements are still evolving, so there must be concern within the government that Boeing's design can keep up.
There was a lot to be made of the fact that their design was all screwed up and that they couldn't fly and they couldn't do this and they were behind and so forth. Not the case at all. To me, it was just an improvement in their design according to the requirements. It was very normal. Very, very normal.
Whatever the future holds for the redesign, at least one of Boeing's nightmares is finally over. George Bible's team has finished the troublesome wing skins and is ready to rush them from Seattle to California. The last pair of panels is loaded onto a C-5 Galaxy, the largest cargo jet in the Air Force.
Boy, I hope the wind doesn't tip her wing over.
Bible scrapped the temperamental thermoplastic and cooked up the wing skins from a more conventional composite. Though heavier and less durable, the new wing coverings are finally on their way to Palmdale, still more or less on time and on budget.
And that's just what happens when you're reaching in technology. Sometimes you're successful and sometimes you're not.
Emotionally, it'll be over for me when I see that airplane disappear over the horizon heading south.
With the wing skins safely in Palmdale, Boeing wastes little time attaching them to the wing box.
Whoa, hold it.
But before the upper skin can be mated to the structure, critical wiring must be installed.
Let's go terminate.
A lone electrician crawls in between the skin and wing box to connect wiring. Working in the dark under the 700-pound wing skin is a grueling job.
I'm gonna need a heat gun.
Hour after hour.
Doing good.
Wire after wire. Each connection is tested and double-checked.
How you doing, Lonnie? Almost done.
You almost done?
Yeah.
How many connect you have to do?
2.
He's been in there for 4.5 hours. Has not come out yet. It's dedication. Now here he comes. See if his leg's still moving. All right, Lonnie, my man.
You ready to clear, Jack?
With the wiring done and the skin lowered into place, mechanics will spend the night hand-tightening thousands of fasteners. Before the wing can be mated to the aircraft, another major piece must first be attached to the fuselage. Like a giant gift, the entire front end of the airplane arrives in the Phantom Works hangar.
Now the work begins.
Can't believe my eyes. Oh, waited for all this time and finally got it. I can't wait to hook it up.
The front end, which includes the cockpit with all its intricate electronics, was built in St. Louis at a former McDonnell Douglas plant, now part of Boeing.
Bring her back another 3 inches.
But will this front end, built 1,800 miles away, made up with the rest of the fuselage? The fit must be as precise as the width of a human hair.
If we bring this down a little further, we'll get the fleshiness a little bit better.
Yeah. Both up together.
Bring her back just a little bit more. Bring her back about a 1/2 inch and we're there. Looking real good.
That's good. That's good.
In less than 2 hours, the installation is complete. And the Boeing X-plane has its distinct face.
It's starting to look like an airplane. That's what's really neat about it. You guys
no, I see a future contract.
Well, that too.
With the addition of the one-piece wing, an apparition appears at the Phantom Works. The recognizable outline of the first of the Boeing X-planes. The company is now weeks ahead of schedule, and morale couldn't be higher.
It went great. Looks like an airplane now. Look at it. Lockheed, watch out.
What Lockheed is watching out for is an end to its crippling parts delay.
You guys ready?
Mechanics finally installed Bulkhead 270, which took 5 long months to carve out of titanium.
No, this way.
Ed Buer nervously waits to see if it will fit. If it does, a plane will quickly take shape around it. If it doesn't, it's game over for Lockheed. Designed on the latest computers, cut with diamond-tipped bits, only to be installed with a sandbag.
That is a beautiful piece of job.
In the race to complete its X-planes, Lockheed still trails Boeing by months. But the manufacturing team plans to fly full throttle to the finish.
Basically, this place is, populated by a bunch of airplane nuts, so it's a very high pace, and that pace is not going to slacken up at all. It's going to continue.
To underscore its commanding lead over Lockheed, Boeing stages a public relations coup at the Phantom Works. In a surprise move, Boeing has assembled both of its test planes for the media event.
Ladies and gentlemen, the X-32A and the X-32B concept demonstrator aircrafts. What do you think?
In an aerospace tradition called rollout, the company shows off its brainchild in 2 different versions to the world. It's a moment of high emotion for Boeing program manager Frank Statkus.
It's everything that we've done for the last 3.5 years. It's all your successes. It's all your thoughts. It's all your weekend work. It's all your overtime. It's a soul that's in that airplane because each and every one of us sweated bullets to put it there.
Rollout is a milestone for the Boeing team. But as things stand now, Frank Statkus with wings would get in the air faster than the X-planes. They may have soul, but they don't yet have brains. Hundreds of thousands of lines of vital software code is still under development to manage every function of the X-planes. That work gets tested here in a multi-million-dollar simulator.
Just yawls in the wind gently.
Boeing's lead test pilot, Fred Knox, puts the faux fighter through its paces.
With the crosswind, how about we look at 20 knots of crosswind, just to give a little outside.
Modern fighters are designed to be aerodynamically unstable.
10, roger that.
Under computer control, that aerial volatility transforms into acrobatic agility.
Reset. Okay, you now have crosswinds. 10-10, roger that.
Every simulated flight by Knox helps refine this essential software.
Flight control software controls the airplane the way it flies, but it also turns on the air conditioner, it raises and lowers the landing gear, it navigates for us, it does every critical element and every critical safety element in the airplane. If we haven't done the development here, the airplane will not fly.
Touchdown.
Yeah.
But less than 2 months after rollout, the software development suddenly goes offline. Boeing is crippled by the largest white-collar strike in American history. 17,000 aerospace engineers are off the job, including more than 100 developing the X-plane's flight controls. Progress inside the Boeing Phantom Works grinds to nearly a halt, while outside, a small group of engineers joins the strike.
It's a bad situation for everybody. Everybody really has real mixed emotions, I think, and is real conflicted about it.
40 days later, the strike ends, but Boeing doesn't escape unscathed.
The strike on our program is a terrible wound. We lost weeks of schedule. Those weeks will not be recovered.
With the setbacks, Boeing's lead over Lockheed evaporates. After years of jousting back and forth, these two combatants are galloping toward the tournament grounds, toward the arena where X-planes and test pilots meet their fate. It's time for this battle to take to the air. Just 30 miles away from the Skunk and Phantom Works lies the proving grounds for all of America's X-planes, Edwards Air Force Base.
Edwards Air Force Base is a tremendous facility, and one of the hallmarks of that facility is the lake bed. It's about 12 miles wide, it's 20 miles long, and it's a very hard, flat surface. And you can put the airplane down, and you don't have to worry about running out of runway because you've got the whole lake bed in front of you.
With these wide open spaces, Edwards and experimental planes go back to the first supersonic flights. Here, the original X-plane, the X-1 flown by Chuck Yeager, broke the sound barrier over half a century ago. Since then, aviation triumphs and tragedies have made Edwards the hallowed ground of X-plane history. Now these skies will hold an epic contest never seen before, a battle between X-planes.
Historically, we have 47 X-plane programs. So this is the first time in history, ever, that any two of those X-airplanes have competed against each other for a production contract. It's unprecedented.
It's time for Boeing's dream to take flight, while Lockheed can only watch from the ground. After years of derision as a second-rate contender, Boeing proves even an underdog, like its X-32, can have its day.
Airman Lorma, this is Freddie Knox from the Boeing Company. We're getting ready to launch that X-32 on his first flight this morning. And I wonder if I could get a little forecast for the winds, say from about 7:30 to
Fred
noon.
Knox, Boeing's chief test pilot and a key developer of the X-plane, will take the craft on its maiden flight.
I appreciate the help this morning. Bye-bye.
It was a good day to go.
It's an excellent day to go.
With the fate of the Boeing effort resting on his shoulders, Knox receives a final blessing from Frank Statkiss.
I'll see you at the other end.
Absolutely. For me, it's about as big a day as a test pilot's ever going to have. A chance to go do a first flight. It's a big day for me. It's a big day for the rest of the team. We spent 4 years now working very hard. Everybody from flight controls to APU pumps to structure, and a lot of hard work. And we should get a nice, safe flight in.
Have a great flight.
Everybody enjoy it too. It's a big day for all of us.
See you guys at Edwards.
Yeah, couldn't be a nicer day.
I'm excited. I'm pumped. We're ready to go. Everybody's smiling. Look at that.
You're looking sharp, sir. F8 forever, you bet.
There's my team.
If Fred Knox is nervous, he doesn't show it, even after finding some stray tools in the cockpit.
Home sweet home. It'll be fun. Thanks, sir.
Knox is alone in the plane. He has plenty of company in the air. 2 chase planes flown by other test pilots will monitor his flight.
It's going to be exciting. Finally, all of our life is in there. Blood, sweat, and tears.
0 or 124.55, squawk 040, hey, 363.0 for departure, 0406 on the punches.
Like proud parents, the weary engineers and mechanics of the Phantom Works gather to see their fighter off.
Now ready for takeoff on runway 7. Be an airborne pickup by the Salty Dog. Control copies, read you loud and clear, and we are ready. and I'm going to go fly.
Today's flight isn't a round trip. The Boeing plane is leaving the Phantom Works for good to take up residence at Edwards Air Force Base, a short distance away.
I got
I was bawling like a baby. Yeah, I mean, it was excitement, you know, and then it was just kind of mainly a huge sense of relief.
Easing the throttle back, it's climbing like a bean's been there. There is.
Within minutes, the X-plane is in the airspace over Edwards, wheels down just in case.
But 11 Alpha 160 looks good. I'm just going to give you a brief.
Knox has flown this plane for hundreds of hours in a simulator. Now he gets to see if the real thing handles the same way.
But 11 Alpha 160 looks good. Hey, I'm happy with the airplane.
Then, Boeing test pilot Dennis O'Donoghue in his chase plane spots a problem.
Truck Irish, on the starboard side, you've got hydraulic fluid leaking from about the forward mid-fuselage. I'm just guessing this is the first flight stuff pouring out a little bit, but we'll watch. It doesn't appear to be dissipating. I'll keep an eye on it. Roger.
With the source of the leak uncertain, Knox is told to cut short his long-awaited flight.
Just going to give you abbreviated test points, and we'll set up for a landing here. 2 numbers off, runway 25, wind 2504, altimeter 3002, clear to the Hawthorne Airport, the Bondo Victor 518. Congratulations, Red. Well done. Well, hey, we got airborne.
There she is, got one flight under her belt.
We dropped a little fluid out of it. We never lost, everything stayed up. It's full normal landing. The flying quality's about 11. O'Donoghue was getting nervous. He couldn't stand the fluid pumping out.
Congratulations. So it's time to land, huh?
Yeah, it was definitely time to land. For the moment I saw it, it was time to land.
The hydraulic leak turns out to be minor, a tiny glitch in an otherwise triumphant day. Over Edwards, Boeing begins a series of test flights. During each one, the pilot puts the plane through a specific set of maneuvers known as test points. Sensors document the plane's flying characteristics. The results go to the JSF. So far, the plane's performance closely mirrors the Boeing simulations, a sign of just how sophisticated computer design has become.
Every pilot has been astounded at how closely the airplane actually matches what we thought it would do, from air speeds and flying qualities and system performance. That's just been a really good surprise.
While this version of the Boeing X-plane is intended for both the Air Force and Navy, it's the Navy requirements that will be the most demanding. Commander Phil Yates, call sign Rowdy, is the official Navy test pilot assigned to the Boeing effort. For him, it was an unexpected honor.
I received a phone call. How would you like to be the first Navy pilot to fly the JSF? Well, after picking my chin up off the ground, I said, yeah, I think I'd like to do that.
Carrier landings are a testament to the precision skill of Navy pilots, and Rowdy is one of the best. In preparation for testing the Boeing X-plane, he takes an F-18 Hornet out for a spin.
Okay, good nozzles, good hydraulic pressure, good RPM. Here's a salute. Here we go.
And we're off. Oh, that's out. Man.
Carrier landings are probably the most demanding task a pilot may be faced with, especially at night in adverse conditions, pitching deck, bad weather. You have to be able to precisely control the airplane.
Flying at about 150 miles per hour, Navy pilots aim for a target zone of only 120 feet. about the size of a tennis court. They must catch one of 4 arresting cables. Pilots don't apply brakes. In fact, at contact with the flight deck, they gun the engine to full power so that if the plane misses the cables, there's enough thrust to get airborne.
If landing on a runway is like threading a belt through a belt loop, landing on a carrier is like threading a needle.
A test pilot's job is to jump into a plane in which he may have little experience and report on its pros and cons.
When you start doing that in an airplane that's never been flown before, that it really is what gets a test pilot, I think, excited.
What's exciting to a test pilot would be sheer terror to most people. Here at Edwards, Rowdy will put Boeing's X-plane through the precision maneuvers of a carrier landing.
Good morning, sir.
We all recognize that these are unproven airplanes, but we as test pilots deal with that we're going to be able to handle any situation that the aircraft presents to us. If we don't feel that way, we wouldn't be flying.
The Boeing team has worked hard to minimize the danger. But the test requires Rowdy to fly so close to the ground, any error or technical problem may be fatal. A section of runway has been marked off, equal to the landing strip on a carrier deck.
God, he goes.
Roger that, Phantom 3.
From a control room miles away, a team of Boeing engineers monitors the X-plane's every move.
Roger that.
Pilot learns what kind of corrections and control inputs he has to make, and then it's also the aircraft's ability to respond to those control inputs. It's that combination that ultimately determines how well the airplane is going to do at the ship.
As he would on a real carrier, Rowdy receives visual cues from an optical landing aid called the Fresnel lens. If he can line up an amber light called the meatball correctly, Rowdy knows he's approaching at a safe angle for a successful touchdown. He gets additional tips from a landing signal officer on the ground. On a real carrier, this officer would give a score to every landing.
I don't want to hear what you say. Low starts in the middle. We're not really trying to grade the pilot on what Rowdy's doing. He's a skilled aviator who knows how to make the corrections. Raj Paul. So what we're trying to look is find out how the airplane is performing with certain deviations applied to it.
With each attempt, the degree of difficulty goes up. To recreate real-world conditions, Rowdy begins an approach descending too fast or at too steep an angle, and then tries to correct for it.
Man, that's amazing.
The X in X-plane means experimental, but occasionally it means unexpected. On one test flight, pilot Dennis O'Donoghue runs into trouble.
We were just doing a routine test with the aircraft to see if we ever lost the engine, could we crank the engine back up and get it relit?
Suddenly, a warning light comes on indicating the X-plane's landing brakes have failed.
Flight control. Flight Talk to me. Do you want it to reset or slow?
You can't reset. You gotta bring it home.
Phantom 3 control, we need you to RTB.
RTB, can I reset?
Negative.
Suspecting the warning light is at fault, O'Donoghue brings the plane into land on the runway. Without brakes, he will quickly run out of room, risking injury to himself and his reputation. Wrecking a multi-million-dollar X-plane doesn't look good on the resume.
And touchdown, press the brake pedals, no response. It was just a matter of adding power, getting airborne again.
Phantom 3 control, we need you to RTB. Roger.
With the brakes definitely gone, it's time for Plan B. Saving a 21st century plane using a 2-million-year-old lake bed.
Had plenty of lake bed in front of me. Touchdown, and just let the aircraft roll to a stop. Had we not had the lake bed, that would have been a much more critical emergency, much more critical.
After a month of successful flights, Boeing's luck has run out. Repairing the brakes reveals a major software problem.
Still read 9s, or you got the 3s? Still read 9s. 4
And the
9s.
plane is grounded.
All right, well.
To make matters worse, Boeing no longer has the skies over Edwards to itself. That very day, Lockheed's X-plane is finally ready to leave its factory home and head into battle.
Funky chicken here.
The X-plane's first flight is in the hands of Chief Test Pilot Tom Morgenfeld.
Ready to go.
Having flown everything from the first stealth fighter to black aircraft that are still classified, Morgenfeld has unrivaled experience. Yet he is all too familiar with the dangers of flight test. In 1992, while piloting an Air Force prototype, a computer malfunction sends Morgenfeld's aircraft into a violent oscillation. After skidding in flames for more than a mile, Morgenfeld walks away unharmed. Now, nearly a decade later, the legendary test pilot is about to climb into another untested fighter.
No turning back now. I think I've committed myself, huh?
The first time you fly an airplane, it's a tremendous thrill. Your heart's pumping and the adrenaline's flowing, believe me.
In a Lockheed tradition, Morgenfeld carries with him the wallets and car keys of assembly manager Ed Buer and the rest of the senior X-plane team. It's a sign of confidence.
Thank you.
And hat trick, on condition, you're clear 2.02.1.
Roger.
I am so filled with emotion right now. Oh, man.
This is fun. All complete, feels great. Roger, you're coming on my count. 3, 2, 1, now. The doors are open. Roger, copy that hat trick.
After 22 minutes, the first flight is over. Lockheed's X-plane touches down at its new home.
Welcome to Edwards, and you're clear for the shutdown. Roger that.
That beautiful man up there right now. Take care of my baby.
We did it, man. We did it. Oh, great, man. What a thrill. Sorry. I had to hold you.
Set me
I
up.
had to hold you.
Good job, man. Good job, man. What an airplane. What an airplane. Hey, Andy.
Yes, yes.
What an airplane.
Oh, yeah.
I want to get you wet.
Magnificent. It was great. It was super. Yeah, thank you very much.
So awesome.
Oh, it felt great. It felt super. Yeah, I wish you'd have done a little bit more. I just wanted to keep on flying. The airplane's ready, too. I mean,
Yeah?
It feels great.
That's
Great God, we couldn't all be
gotta get to the winner.
We're going to fly the out of this airplane and just kick every day. That's what it's all about.
True to Rezebek's word, the Lockheed X-plane is back in the sky the very next day. A carefully orchestrated series of maneuvers slowly reveals this jet's true capabilities.
Baby steps is a very good way to put it. Very small, analytical, incremental steps. We don't want to go out and push the airplane or the pilot or the test team beyond their capabilities.
Lieutenant Colonel Paul Smith, call sign TP, is the JSF's chief test pilot brought in from the Air Force and assigned to the Lockheed effort. Like all the pilots, he spent hours in the simulator, but it didn't quite prepare him for the feel of the real thing.
Probably the most incredible experience I felt was the enormous power behind me with the engine. I've never had this happen to me, but it's probably synonymous with being shot out of a fire hose. Just a very steady, incredible amount of acceleration right through your back, and the feeling like this was a stallion that was ready to go anywhere, any place I wanted it to, and if I just let it go, it would go there.
The Lockheed plane is like a stallion in another way as well. Like all fighters, when it comes to fuel, it eats like a horse. While not a JSF requirement, Lockheed wants to tank up its plane through aerial refueling. And to make up for lost time, Lockheed's ambitious test schedule depends on it.
There was a lot of pressure to get the aerial fueling certification done so we could start tanking. The amount of time we could spend in the air before that was about 30 minutes, realistically, and that was just not enough time to get everything done that we need to get done.
With only 2 flights in the X-plane under his belt, TP will attempt one of the most dangerous missions of the Lockheed program.
Air-to-air tanking has always been kind of intimidating to me because throughout my career I've been taught don't let anything touch your airplane. Don't let another aircraft hit it. Don't let ground fire hit it. Don't let missiles hit it. And then the first thing you do is you go up to this tanker and the tanker hits you.
At 20,000 feet, TP rendezvous with a KC-135, heavily loaded with fuel. The tanker slowly extends a boom towards a receptacle located behind the cockpit of the X-plane.
It's really a basic feeling of trust between you and the guy flying the boom to make sure he doesn't hit the airplane where he's not supposed to.
TP cautiously edges closer.
At that point, you just have to fly very stable because he's trying to plug that boom in the back of the aircraft.
Running low on fuel, with only minutes before having to abort, TP makes contact.
And you can actually feel it in the airplanes. You feel like you are part of the tanker and it can actually fly you around. But at that point, you just kind of relax or try to relax and stay in that same position while you download gas.
X-plane and tanker are now coupled in tight formation at 350 miles per hour. Less than 5 minutes later, the crucial maneuver is over.
This airplane flew tremendously well on the boom, better than any other airplane I've flown. And so it was very easy to get confident in yourself and confident in the airplane very quickly.
For the competition, Lockheed designed its X-plane to use the Air Force system of aerial refueling. But Boeing's gone with the Navy's version. With its software bugs fixed, Boeing's X-plane is back in the air. Navy planes have a fuel probe designed to plug into a drogue basket at the end of a hose dangling from the tanker. But during Boeing's first refueling attempt, the basket flies dangerously close to instruments mounted on the nose. These test sensors are used only for evaluating the plane's performance. But if the basket breaks them off, they may be sucked into the engine. That could bring down the plane. And that's not the only problem. When the refueling basket makes it onto the probe, it fails to seat properly, sending gas everywhere but the tank. In a blow to the Boeing effort, aerial refueling is ruled out as too dangerous.
I'm sure that Boeing's engineering staff was somewhat puzzled by all this. There was some serious study work done. There were a lot of engineering studies that were conducted, but converting that data to the full-scale finished artifact is oftentimes a little bit of a magical process, and it doesn't always work out.
For the remainder of flight testing, the Boeing X-plane gets its gas on the ground. And the company's month head start on Lockheed drips away.
Every time they have to land and refuel, they're losing time. While they're doing that, Lockheed Martin is in the air and they're completing all their flight test objectives.
For Lockheed, one goal has remained out of reach. In a month of test flights, its X-plane achieves Mach 0.98, just short of breaking the sound barrier. Like aerial refueling, the JSF doesn't require a demonstration of supersonic flight. But with only 3 more test flights of this version of their X-plane left, Lockheed wants to hear the boom.
Today we're going to go supersonic for the first time. It's an emotional victory as much as anything else.
People understand supersonic that work in this industry, and it's a very, very big thing. The crew has worked out here for now approaching 30 days, 7 days a week, 12 hours a day. And it's nice to give them a lift.
Where is he now?
The Lockheed X-plane team has struggled with a host of small but stubborn problems that have kept the plane subsonic. But at the end of a long day of flying, with test pilot Morgenfeld at the controls, all that is forgotten when the Lockheed plane crosses the boundary first shattered in the same skies by the very first X-plane. Lighting the afterburner provides the extra push needed to go supersonic.
That was Tommy. Did you hear that?
It means a very successful end to a hugely successful first month of flying X-35s.
Lockheed arrived late to flight test, but made up for it with a record-setting performance for an X-plane. 27 flights in 30 days.
I was just a victim.
A month later, Boeing's X-plane goes supersonic as well. The aircraft's grace in the air and strong test results have quieted the critics of its less than sleek shape. Driven by the competition, each company has taken its X-plane to new levels of performance, only to see its adversary do the same.
You had 2 aircraft prototypes, and yet they were flying several times a day. And this is unheard of for X-planes. And it's a testament to both designs and both design teams that they were able to do this.
Both teams set out to demonstrate a certain number of test points. They both seem to have done it. Both aircraft flew. They were pretty reliable. I don't think there's anything that's come out of this stage of the program that would say that one or the other is going to win.
A Boeing airplane is much more of a competitor than anybody, in particular Lockheed, really expected. I don't see any distinct advantage to either airplane. At this stage of the game, I'd have to tell you that it is neck and neck.
Both Boeing and Lockheed realize the entire competition and the largest military contract ever may come down to the JSF's final requirement, achieving the Harrier trick of landing vertically. Houdini once made a 5-ton elephant disappear. Lockheed plans an even greater feat, to levitate over 3 times that weight. A 17-ton fighter using its radical new lift fan. The fate of the competition, perhaps even the fate of the company, rests on this untested system.
All of their eggs are in this one basket. If they do lose, effectively Lockheed Martin is a fighter production entity in the United States. That will come to an end. They have nothing else to keep their front doors open.
Lockheed engineers install their lift fan system into the X-plane, hopefully transforming it into that hybrid of the skies, a vertically landing jet. While it remains unproven, the concept behind their unique lift fan system exudes engineering elegance. 2 columns of air instead of 1 in the Harrier balance the plane's descent. 1 column is the engine exhaust directed downward. The other column is created by a lift fan connected to the engine by a drive shaft. The fan takes in air from above and blasts it out below. It's an ingenious system, but in practice, it requires a symphony of moving parts.
Lockheed has chosen a very complex solution. If something goes mechanically, catastrophically wrong during the hover, you have very, very little time to get out.
A former Royal Navy pilot with Harrier combat experience in the Falklands and Bosnia, Simon Hargraves will attempt the first hover in the Lockheed X-plane. He spent years in preparation. Still, there's no question, he's about to take a ride on the wild side.
Nobody's ever tried to model a propulsion system that's quite as complex as this, quite as integrated as this. So there may be some areas there where the airplane doesn't respond exactly as I'm expecting.
The vertical landing tests will start over a hover pit, 10 feet deep and covered by a steel grate. The hover pit is designed to minimize the chance the engine will suck in its own hot exhaust. Hot gas ingestion is a familiar danger to Harrier pilots. If the exhaust used to float the plane somehow enters the engine's air intake, the engine will start to choke.
What happens when you ingest hot gas, your thrust decays. Your thrust decays, you lose lift, you start descending at a rapid rate and can lead to a catastrophic accident.
Venting the hot gases out the side of the hover pit provides some protection.
This will go well. Here we go. 70%. Throttle up. Nose up. Come on, Simon. Come on, baby.
Hargrave holds steady 20 feet in the air. At 35,000 pounds, it's the heaviest fighter ever to hover.
Wow.
The lift fan performs without incident and produces 1,500 pounds more thrust than predicted.
That was great. That was incredible. Let's do that again. Incredible.
After nearly 2 years of struggling to keep up with Boeing, the Lockheed team now has reason to display their usual abundance of self-confidence.
We've never had a doubt in our minds at any point in this program that this is the right type of airplane and propulsion system, and we felt very sorry for the competing team against us. I never felt sorry for him. Yeah, that's true.
While the lift fan works, Lockheed still hasn't accomplished the tricky mid-air maneuver called conversion, going from level flight to vertical landing with its complicated dance of moving parts. The same morning Lockheed lifts off, Boeing plans a dramatic demonstration of its own vertical lift system. The company's second X-plane has been flown across the country. The new proximity to Washington decision-makers and lobbyists doesn't hurt. But the real advantage is invisible. The air at sea level has greater density than at the high-altitude location of Edwards Air Force Base. Thicker air means better engine performance.
VMS, talk to me. I gotta do it fast.
In this test of its direct lift system, Boeing hopes to outdo Lockheed. Test pilot Dennis O'Donoghue will start in level flight, slow the plane down to nothing and hover. His slow speed will make the wings useless, and a failure of the lift system will mean the plane falls from the sky. To give O'Donoghue a chance to eject, Boeing has conducted its early tests at higher altitudes, gradually working lower and slower. Now, after 43 flights, Boeing is ready to go all the way to attempt zero airspeed.
I've got butterflies.
O'Donoghue's family is among the spectators of today's historic event.
The boys are really excited too. I think Dennis slept because he knew he needed to. The boys slept. I didn't sleep a wink. Look at Daddy's airplane. Dad! Yes!
200 feet above the runway, O'Donoghue slowly decelerates to zero airspeed and hovers. A 28,000-pound airplane hangs frozen in the sky.
Looked good here. Yeah, the home performance looked real good. Numbers were looking pretty nice, especially RIT. And guess what, American pilot? Yeah, you are my hero. Pretty cool, huh? You got that right. Congratulations, Irish. Slowest man alive again.
I didn't think he was ever going to get off the
Oh my God, what a day. I'm sitting there yelling and clapping and crying, driving up and seeing him just right there.
On this day, the Boeing X-plane hovers 4 times, once for 2.5 minutes. And demonstrating rock-solid control, performs a perfect 360-degree turn.
Business views are pretty good. One more time. Hey, very good to affect the pedal string. Hold on, going really well. Very comfortable airplane to fly on over. 1 minute. 1 minute.
It was just wonderful. Brendan said it was better than Star Wars, and for him, that's a lot.
One month later, Boeing is ready to make history. If it works, its X-plane will become the first new fighter since the Harrier to transition from conventional flight to landing vertically. For this risky mission, Boeing will also use a hover pit to reduce the chances of hot exhaust being ingested into the engine during the landing. To increase the margin of safety, Boeing engineers have removed some exterior parts to lighten the X-plane's weight. Some critics will cry foul, but Boeing will respond that its new design, which it didn't have time to build but will submit to the JSF as its final proposal, is 1,500 pounds lighter. Dennis O'Donoghue is in the cockpit again, while flight test conductor Howard Goffis will closely monitor the mission from the ground.
Now, there's fewer unknowns. We know we can do it. We know we've been there. We know what we've seen so far, but we're still only one failure away from having a really bad day.
Okay, coming to 50 feet. Here we go.
Closing in over the pit, the Boeing X-plane comes to a stop and begins a slow descent. If disaster strikes, O'Donoghue is now too low to eject.
T2. He's over. T2. Not across that one. I know, we're coming down.
Suddenly, the controllers spot trouble.
That's good.
Invisibly, the engine has ingested hot gas from the lift nozzles and loses power.
Not across that one.
O'Donoghue feels the bottom dropping out, but it's too late to abort. 20 feet and only seconds from the ground, the gas dissipates, and the engine gains enough thrust to touch down safely.
Excellent landing.
He's down on the ground, and we realize it, and so there's you're in the quandary for that split second. Okay, we just did our first VL. What happened?
Over by the runway, no one is aware of the close call. Reviewing the data, the test team believes a choice made to increase safety, the hover pit, may be causing the problem. There's almost no crosswind to clear the pit of exhaust. Hot gas may be collecting and bouncing upward into the air. They decide to attempt a second vertical landing, but on a solid surface.
We decided we were going to go for the vertical landing on the pad. So we set up all the numbers, set it all up, and know that, hey, the same thing could happen there.
Looking good so far, TCN1.
The second vertical landing goes without a hitch, to everyone's enormous relief.
Hey, Howard. Yes, sir. We did it. Yes, sir.
But just a week later, during another vertical landing, an old friend pays an unwelcome visit. It's a pop stall, the result of hot gas ingestion just above the ground, a common event in Harriers. Boeing engineers predicted it might happen and designed it out of their new version. But they decide to play it safe and stop testing their vertical system. A month later, Boeing completes all major requirements for the Pentagon ahead of the competition. It's a major landmark, and if anything has them worried, the Boeing executives certainly don't show it.
It felt great. It looked great. It felt great, yeah.
I'm confident that we are the head of the class now, and I expect to stay there.
All right, one more time.
The Lockheed plane now needs to prove it's ready for prime time by performing the critical transition from conventional flight to hover to landing vertically.
We need to demonstrate that we can land on a solid surface, both to make sure we've got the performance and the flying qualities to do that, to make sure that we've dealt with ground effects such as hot gas ingestion, and to prove that we can land on a normal sort of surface without damage or significant erosion to the surface.
Okay, converting in 3, 2, 1, now.
At 1,000 feet, Simon Hargraves engages the lift fan and slows down. With air from the front and exhaust from the rear nozzle in balance, the Lockheed X-plane floats on nearly 40,000 pounds of thrust. This system avoids the problems of the Harrier and Boeing's direct lift. Cooler air from the lift fan creates an invisible barrier that prevents the engine from choking on its own hot gas.
And coming down, right in the middle of the pad. Oh, the stop isn't quite right. Let's keep it going down.
After 2 minutes of hovering, Hargraves eases off the throttle and gently guides the X-plane down.
Yes, beautiful. No problems at all. Well done, Simon.
Good job. Simon, honor. Yeah, great. Easy.
Great, Simon, it looked like you've been doing that for 20 years.
It felt like it, yeah.
It's been a long time coming, and that's the only thing I can say is
yes!
It's going to be a tough choice. If one guy had stumbled here at the end, then it would have made it easy.
It's not an easy choice, and that's what the government wanted. The government wanted the close horse race, and I think they're going to get it now.
In the waning days of the competition, at an undisclosed location somewhere near the Pentagon, JSF Director General Michael Howe takes Nova inside a world where cameras have never been allowed. Behind a wall of security, the secret proposals of Boeing and Lockheed are being evaluated by the government team that will help determine the winner of the Joint Strike Fighter program.
This is where the proposals are, all electronic, of course. This is where we've got 200 people off and on coming in to look at the proposals one at a time, gauging them against the operational requirements document.
Digging through mountains of data, experts evaluate performance, cost, management, and risk.
Some of them are doing aerodynamic performance, figuring out how fast will it go, what is the range, how will it turn, what kind of G's can it sustain. Others are evaluating software and architecture.
Now, near the end of this jury process, the results are one of JSF's most closely guarded secrets.
We got about 6 weeks left by which we're going to take the results of our evaluation, give to the Secretary of the Air Force, who in harmony with the Secretary of the Navy is going to make a decision of who's going to build the airplane for the warfighter for the next 40 years.
As the final decision approaches, known in military speak as down select, Boeing remains confident that its manufacturing know-how and cost-saving designs have made it a winner.
I think we all feel pretty good about going into down select, and I think we truly believe that we've got the right vehicle for the customer.
But just before it crosses the finish line, Lockheed plans a final dramatic display, a bid for the history books, and bait for the huge government contract. In a test flight Lockheed dubs Mission X, its fighter takes off in less than 500 feet, then goes supersonic and lands vertically. Since the Harrier is subsonic, the maneuver is a milestone in aviation history and a direct hit on Boeing's need to strip off parts for vertical landing and reinstall them for supersonic flight. But the Lockheed team pushes its luck too far. They attempt a vertical takeoff and transition to conventional flight. When the plane bobbles in the wind on liftoff, the mission is aborted. But the failure does nothing to dampen Lockheed's legendary mix of technical ingenuity and engineering arrogance. This company believes it has won the right to build the first fighter of the 21st century.
We did our part of the bargain. Now the rest of it's up to the government.
Five years after the battle began, it's D-Day. The decision is in the bag. The contractors anxiously await the news. In Palmdale, California, Rick Rezabek and a few hundred members of the Lockheed team gather in the X-plane hangar.
We did as much as we needed to win this thing in very, I don't know, comfortably, anxiously, nervous, and confident.
Did the best we could.
Yeah.
Did the best we could.
While in an office in Seattle, the leader of Boeing's X-plane program, Frank Statkis, and company vice chairman Harry Stonecipher stand by for word.
Where are we going to be able to watch this thing from? Right here. Let's watch it.
We're here today to announce the largest acquisition program in the history of the Department of Defense, the Joint Strike Fighter. The value of the program could be in excess of $200 billion. Two contractor teams, one led by Lockheed Martin and the other led by Boeing, have just completed a concept development phase. Both contractor teams met or exceeded the performance objectives established for the aircraft.
The process involved at the end was about 250 people.
And both proposals were very good, both demo programs were very good, but on the basis of
Strengths, weaknesses, degrees of risk of the program. It is our conclusion, joined in by our colleagues from the United Kingdom,
that the Lockheed Martin team is the winner of the Joint Strike Fighter program on a best value basis.
Is the winner of the Joint Strike Fighter program on a best value basis. Frank, tell your team they did an unbelievably good job. I
asked for more.
In a call from Washington, Boeing CEO Phil Condit consoles his team.
Is it a winner-take-all, Phil? Well, at this point, the answer is yes. This decision they've held to the winner-take-all.
You did a great job.
I'm sorry.
No, you did a great job. Because I don't know what.
In my mind, the Boeing redesign, the hot gas ingestion, makes me wonder if for Boeing to win, Lockheed's lift fan engine had to fail.
One of the biggest deciding factors in this competition, in my opinion, was that Boeing never managed to make a vertical landing with the aircraft in complete configuration. They took the inlet cowl off, they took the landing gear doors off. Lockheed Martin made complete vertical landings with the aircraft in the same trim that it could go to supersonic speed in.
The X-35, now officially designated the F-35, may become the most widely deployed fighter ever produced.
That looks good.
I think it's ironic that Lockheed, in 1943, in effect gave birth, under the auspices of the Skunk Works, to the Lockheed P-80, which was the first successful operational jet fighter used by the U.S. military. And here it is almost 60 years later, and they are now the winner of the JSF competition, which could result in potentially the last manned jet fighter. It's the closing of a major chapter in the history of U.S. air power.
With a buy-in from the services and billions in foreign sales, the future of the F-35 looks bright. But fasten your seatbelts. There may be turbulence ahead.
Now the fun really begins, because Lockheed has to deliver on its cost and performance promises for the JSF. And the government's already talking about cutting the number of airplanes it's going to buy and spending more on unmanned combat air vehicles.
And who's one of the top builders of unmanned combat air vehicles? Boeing. Losing the battle of the X-planes may not mean losing the war to dominate the future of American air power.
So the last chapter in the JSF story is really yet to be written.
What was it like to be the only TV journalist allowed to